Welcome to this class. Today I am going to continue the chapter Force and Motion of class 9, and this is taken in unit 7, and today's focus is on Newton's third law of motion and plasticity and elasticity. Okay, let's start. But before starting the class, I want to tell you something related to the previous class. I want to recall some of the matter from previous class, and then we'll start Newton's third law of motion. Do you remember this? Newton gave 3 laws of motion. First, Newton's first law of motion. Second, Newton's second law of motion. And third, Newton's third law of motion. First law and second law was taught in previous class. I want to recall very fastly. Let's talk about them. What is Newton's first law of motion? According to Newton's first law of motion, every body continues its state of rest or motion in a straight line unless an external force acts on it to change its state. And we have learned about this. According to Newton's first law of motion, every body continues in a state of rest or uniform motion in a straight line unless an external force acts on it to change its state. What is the meaning of this law? Can you see the first part of the law? Look at the first part. What is written here? According to Newton's first law of motion, every body continues its state of rest or uniform motion. What it mean? They have tendency to continue their state of rest and motion, and this tendency of the body is called inertia. And that's why Newton's first law tells us about the inertia of the body. And look at the second part. Unless an external force acts on it to change its state. What it mean? Unless an external force is applied on the body, what happens to the body? It continues its state of rest or uniform motion. What it mean? It means if force is applied, then it can change the state of rest or motion. It means force is an agent which can change the state of rest or motion of the body. It means Newton's first law of motion gives us the definition of force. The second part of this law gives the definition of force. This way, we have to understand this clearly. Newton's first law of motion gives us inertia, and it says the definition of force also. Now let's talk about Newton's second law of motion. Have a quick look. What was taught in last class? According to Newton's second law of motion, acceleration produced on a body is directly proportional to force and inversely proportional to the mass. Do you remember this? And this way, Newton's second law was explained like this. According to Newton's second law of motion, acceleration produced on a body is directly proportional to the force applied and inversely proportional to the mass of the body. With the help of this law, we proved F equal to ma. F equal to ma. The equation is obtained by Newton's second law of motion. What it mean? It means we can calculate the force acting on a body with the help of its mass and acceleration. It means second law of motion gives us not the definition of force, it gives us the measurement of force. First law gave us definition of force. In this second law, we get what? Measurement of force by applying this equation. That's why I can say that measurement of force can be obtained by Newton's second law of motion. But Newton's second law of motion can be written this way also. Just new matter I want to tell you. In the context of momentum, we can say that the rate of change of momentum is directly proportional to the force applied, and the change takes place in the direction of force. What is the meaning of this saying? Rate of change of momentum is directly proportional to force. First, we have to understand about the momentum. Do you know the product of mass and velocity is called momentum? The product of mass and velocity is momentum. If a body is moving in such a way that its velocity goes on increasing and increasing and increasing, then what happens? The final momentum will be mv, product of mass and velocity, and initial momentum will be mu, the product of mass and velocity. And if we subtract this mu with mv, then what we get? Change of momentum. And if it is divided by time taken to gain this change, then we'll get rate of change of momentum. Mass, product of mass and velocity is momentum, final velocity is mv, initial momentum is mu, and if it is divided by time, then we get rate of change of momentum. According to this law, rate of change of momentum is directly proportional to the force. That's why I can say this force is directly proportional to rate of change of momentum. And now let's go forward. If mv minus mu in this part, if m is taken as common, then we'll have v minus u, t remains same, or f is directly proportional to m. v minus u by t is acceleration, because we know that acceleration is equal to final velocity minus initial velocity by time taken. It was taught in previous class also. Now we got this. And if any quantities are proportional, then there must be a constant between them. It was taught in previous class, and that constant was taken as k. It was explained nicely in previous class. That's why I don't want to explain a lot. kma. If force is measured in Newton, mass in kilogram, and acceleration in meter per second square, then value of k becomes 1. That's why we can conclude that F is equal to ma. This way, we can calculate F equal to ma by using this second part. I mean to say, this is Newton's second law of motion. That's why I told you Newton's second law of motion in another way also. What? The rate of change of momentum is directly proportional to force. If more force is applied on a body, change of momentum will be more, and less force is if constantly acting on the body, then rate of change of momentum will be less. Okay. Now I want to come back to our real matter, that is Newton's third law of motion. Now let's start. Now I want to show you some video clip. With the help of this video clip, try to understand what we are going to learn. A woman is swimming here, and rocket is moving upward in second diagram, in second video clip. A man is throwing a ball on the wall, and again it is returned to his hand. Another, look at this, a man is moving in a boat, and looking at this we can understand that they are newly married couple and moving somewhere. Okay, this is a girl and she is shooting something with the help of gun. And here a man is walking, a handsome boy is walking in such a way that he don't care anything at all. Very nice walking. Now look at this. This is tug of war. There are two teams. Each of the team are trying to pull another team towards themselves. And look at this is another video clip. Air is released from the balloon. When air is released from the balloon is moving away. And in this, a pile of book is placed on the table. And this is a balloon is moving across a thread. It is attached with the thread and it is moving like an aeroplane. All these, looking at all these, do you know all these are related to Newton's third law of motion? Just think about this. How are they related to Newton's third law of motion? I want to tell you first, Newton's third law of motion. And then we are going to relate each and every video clip with Newton's third law of motion and how Newton's third law of motion is acting in these activities. Let's talk about Newton's third law of motion. according to Newton's third law of motion, to every action there is equal and opposite reaction. So we can say, according to Newton's third law of motion, to every action there is equal and opposite reaction. It can be understood this way also. Let's say these two are the material we have taken. If first one is dropped over another, then certainly first one applies force on the second one. This is the direction of the force. And don't think that the first one only applies force on the second, but second also applies force in the opposite direction to the first one. First object applies force to the second one, second object applies force to the first one, and the force applied by first is called action, and the force applied by the second on the first is called reaction. And the value of action and reaction are equal. If it is 100 Newton, I mean to say action force is if 100 Newton, then reaction force will also be 100 Newton. In this way, Newton's third law of motion says that to every action there is equal and opposite reaction. Here, action and reaction both are forces. And if first body applies force on the second, then second also applies the equal amount of force on the first, but in opposite direction. One is called action. Because of action, reaction force is produced. This is the explanation of Newton's third law of motion. This is law which is seen in this screen. But now I'm going to explain what I told you a little nicely. We have to understand Newton's third law of motion. That's why explanation should also be clear to you. Look at this. The action and the reaction both are forces. According to this law, force never exists single. It always exists in pair. When a force is produced or applied on a body, then another force also exerts from the opposite direction by the second body. First one is known as action and the second one is known as reaction. According to the law, magnitude of action and reaction are equal, but they act in opposite direction. This is the explanation about Newton's third law of motion. Looking at all these, have you noticed? We are talking about the property of force. How? Force never exists single. It always exists in pair. And first one is action, second is reaction. Looking at all these, we are talking about the property of force. That's why Newton's third law of motion gives us the property of force. So let's come back to first, second and third law, what it says about the force. First law gives the definition of force, second law gives the measurement of force, and third law gives the property of force. Now we are concerned with Newton's third law of motion only in this class. That's why I want to focus this Newton's third law of motion with different example what was shown in the previous video clips. Let's talk about them one by one. Newton's third law of motion acts while swimming. Okay, look at this video clip. A girl is swimming. While swimming, she is pulling water. This is freestyle swimming. She is pulling water towards backward direction in this way. Yes? And the force applied on the water to pull it backward is action. And according to Newton's third law of motion, to every action there is equal and opposite reaction. That's why water produces a reaction force on the body of the swimmer to move forward. This way, Newton's third law is acting while swimming. We can say this way, while swimming, the force by which our hand pulls water in the backward direction is action. According to Newton's third law of motion, to every action there is equal and opposite reaction. Therefore, water exerts an equal amount of reaction force on the body of swimmer to move forward. Okay, this is the reason how this third law is acting on the swimmer. Now let's talk about second. This is what? Rockets are moving upward. They are launched from certain launch pad. It's moving upward. How it is moving upward? At first, the gases produced due to the burning of the fuel in the rocket is coming downward, and it exerts force in the downward direction. And to every action there is equal and opposite reaction. That's why a force exerts on the rocket which pushes the rocket upward. This way, in case of flying rocket also, this Newton's third law of motion is acting. We can explain this way. The force with which the gas produced by the burning of fuel comes downward is action. According to Newton's third law of motion, to every action there is equal and opposite reaction. Therefore, an equal amount of reaction force is produced in the opposite direction, that is towards the upward direction, due to which a rocket moves upward. This way we can relate Newton's third law of motion in case of flying rocket. Now look at this third one. A person is doing something. Have you noticed? He is throwing a ball on the wall. Again, ball is coming back to his hand. Can you relate this with Newton's third law of motion? Certainly. When a ball is thrown on the wall, the force applied by the ball on the wall is action, and according to third law of motion, to every action there is equal and opposite reaction. That's why the wall applies equal amount of force on the ball. Because of this reaction force, again ball comes back to his hand. It can be written this way. The force applied by the ball on the wall is action. According to Newton's third law of motion, to every action there is equal and opposite reaction. Hence, the wall exerts an equal amount of reaction force on the ball, due to which the ball returns back to our hand. I'm talking about this question. Why? Because these questions are famous all over the world, and these are taken in the as an example to explain Newton's third law of motion. That's why these are important. So we are talking a lot about this. Look at this. This is a boating process. A man is moving oars in the forward direction. I mean to say, oar is moved forward and water is pushed forward, and the boat is moving backward. And why? Why it happens? Because here Newton's third law of motion is acting. The force with which water is pushed away forward, water is pushed forward is action, and to every action there is equal and opposite reaction. That's why water exerts a force on the oars, due to which the boat is pushed backward. This way it works. That's why we can say the force applied by the oars to push the water forward is action. According to Newton's third law of motion, to every action there is equal and opposite reaction. Hence, water exerts an equal amount of reaction force on the oars, due to which the boat moves backward. This is about the boat. Now let's talk about this case. What is seen? A girl is shooting something with the help of a gun. But have you noticed that? She holds the gun tightly on her shoulder. And this is necessary to shoot the target. Why? If it is not so, then the reaction force pushes her. Sometimes it may hurt the shooter also. So, how Newton's third law of motion is acting here? The force with which the bullet moves forward is action. And according to Newton's third law of motion, to every action there is equal and opposite reaction. That's why the gun recoils. Gun pushes the soldier backward, and that's why to prevent ourselves we have to hold it very tightly on the soldier. That's why we can say this way: when a gun is fired, bullet moves forward by the action force. According to the Newton's third law of motion, an equal amount of reaction force produces in the opposite direction, that is towards back. The reaction force can hurt the shooter. Therefore, the gun should be held tightly against the soldier to resist the reaction force. This is the case of gunfire, in which the Newton's third law of motion is acting. Okay, now next, look at this. Newton's third law of motion involves while walking. Look at this man. He's walking so nicely, but he don't know how it is possible. We normally walk and we don't know how Newton's third law is acting while walking. Do you know that while walking, our feet pushes the ground backward this way? We push the ground backward. This is action force. And according to Newton's third law of motion, the reaction force produces. It means ground applies the force on our feet to move our body forward. And because of this reaction force only, we'll be able to walk. Otherwise, walking is not possible. So we can say that the force exerted by our feet on the ground to push the ground towards back is action. According to Newton's third law of motion, to every action there is equal and opposite reaction. Therefore, ground exerts an equal amount of force on the feet to move the body forward. That is reaction. Thus, due to the reaction force, a man can walk on the ground. This is Newton's third law of motion applied in walking. Now let's talk about another. We have few examples left. We'll finish all these because these are very, very important and taken as example all over the world. And we have also given these examples in our book in different sectors. Okay, Newton's third law of motion in tug of war. Do you know what is tug of war? This is tug of war. What it means? There are two teams trying to pull each other towards themselves with the help of a rope. A strong rope is pulled by two teams. Team A tries to pull Team B towards themselves. I mean to say the force exerted by Team A on Team B is action, and the force exerted by Team B on Team A is reaction. If these two forces are equal, then tug of war exists. When it becomes unequal, then tug of war finishes. This way, Newton's third law of motion is acting in this process, tug of war. Okay, how can we write thirdly about this tug of war? How Newton's third law is acting in this tug of war? We can say this way. Force applied by Team A on Team B is action. According to Newton's third law of motion, to every action there is equal and opposite reaction. Therefore, Team B also applies the equal amount of force, that is reaction force, to balance the force of Team A. Thus, the Newton's third law involves in the game, and the game will exist till both the forces balance each other. This way we can explain it. The Newton's third law of motion, how it acts in tug of war. Okay, let's go to another one. This is a balloon. Very nice appearance. Look at this. We can blow the balloon and holding its mouth. If a inflated balloon is left in air, then what happens? Certainly, air comes out. And if air comes out in the backward direction, then the balloon moves forward in the forward direction. And this way, Newton's third law is acting. The force with which air coming out from the balloon is action. And as a result of this action, the reaction produces in the opposite direction. That's why balloon moves forward. This can be explained this way. The force by which air comes out of the balloon is action. According to Newton's third law of motion, to every action there is equal and opposite reaction. Therefore, an equal amount of reaction force produces in the opposite direction, due to which balloon moves forward. Okay, now what about this? This book is taken on the table. If book is placed on the table, certainly book applies force on the table. This is action. And if it has to be stable, then table should apply the equal amount of force on the book. If it is not so, then the force applied by the book will break the table. If there is only one force, that is the weight force of the book, then it can break the table, but it cannot break the table. What is the reason? The reason is very simple. The reaction force produces in the opposite direction towards the book by the table, which resists the action force. So, book becomes stable on the table. This way we can say shortly, the force exerted by the book on the table is action. According to Newton's third law of motion, to every action there is equal and opposite reaction. Therefore, the table also exerts equal amount of force on the book in the upward direction to balance the action force. Thus, due to the equal action and reaction forces, book becomes stable. Now this number 10, I want to suggest you to do this at home also. Have you noticed this? What is done here? A thread is tied and a balloon is attached with it. We can use a paper cylinder of the thread reel to attach this balloon with the thread. And after blowing the balloon, if its mouth is tightly held, and if we release air from the balloon, then what is seen? Balloon moves along the thread, I mean to say along the length of the thread. It moves forward like an aeroplane. Why? Because the force with which air is released backward is action, and according to third law of motion, reaction force of same amount produces in the opposite direction, and because of this reaction force, balloon moves forward like an aeroplane. You can do this at home also. Now, how can we explain this? When air is released from a balloon, which is loosely held or loosely attached to a thread, then the balloon moves forward due to the reaction force produced in the opposite direction to the direction of release of air. According to Newton's third law of motion, air released backward is action and the balloon moved forward is reaction. And this way it works. Okay, I think this is enough. I told you 10 different examples related to what? Newton's third law of motion. At last you have to remember that to every action there is equal and opposite reaction. Both action and reaction are forces and they have equal magnitude. They act in opposite direction. But one point you have to note. Action force exerted by a body on the second body produces the reaction force by second body on the first. They never act on the single body. First body applies action on the second. Second produces reaction on the first. This we have to remember. Okay, now after this, let's go to another part. I want to talk about the elasticity and plasticity. What is it? Elasticity and plasticity. To understand this very clearly, we must have a little idea about the deforming force and restoring force. Look at this, deforming force and restoring force. Then only we'll be able to understand elasticity and plasticity. What they mean? A force that causes the change in shape and size or the structure of an object is called deforming force. Just for example, this is a rubber band. If I pull it, then certainly the force applied on the rubber band deforms the shape. Length is increased, thickness is decreased. It is deformed, isn't it? Until and unless we pull the rubber band, if we keep on pulling the rubber band, it is deformed. But when we release the force, then it comes back to its initial shape and size. The deforming force means the force that causes the change in the shape and size or the structure of the object is called deforming force. This is deforming force. And deforming force may be squeezing force or twisting or pulling apart, etc. of the object produces deforming force. This produces deforming force. Now it is of two types. One is called permanent deformation. Deforming force can produce permanent deformation or temporary deformation. I mean to say, deforming force acting on a body can deform the body permanently or temporarily. What is permanent deformation? It is known as plastic deformation. It is irreversible. What? Permanent deformation is irreversible. If I pull this using a lot of force, then it will break, permanently deformed. That's why it is known as plastic deformation. It is irreversible. It is a type of deformation that stays even after the removal of applied force. When I stop applying force, then what happens? This rubber band is already broken down and permanently it is deformed. This is called permanent deformation. But there is another term also, temporary deformation. What it means? It is known as elastic deformation. It is reversible. This, if it is not deformed, I mean to say permanently not deformed, if I apply a little amount of force, its length increased, thickness decreased, but still it regains its position. Then this is temporary deformation. It is known as elastic deformation. It is reversible. It is a type of deformation that disappears after the removal of applied force. When I stop applying force, then no effect on this rubber band. This is actually temporary deformation. Now, restoring force means what? Restoring force is defined as the force responsible for bringing a body back to its original shape, size and position. Just for example, once it is pulled and if force is released, then what happens? It comes to its original shape and size, and this is gained by itself, by this body. This is called restoring force contained in this body, contained in the molecule or atoms of this body. Now it's time to talk about elasticity. After the understanding of the deformation, we can talk about elasticity. What is it? Elasticity is the ability of a deformed material body to return to its original shape and size when the deforming force applied on it is removed. Elasticity means the tendency of the body to regain its initial shape and size. This is elasticity. And what is plasticity? Plasticity means plasticity or plastic deformation is the ability of a solid material to undergo permanent deformation or the non-reversible change of shape in response to applied forces. Just for example, if we make a dough of clay and it is converted to brick, giving it a shape like brick, if it is heated, then what happens? Permanently it converts to certain shape. This is the plasticity of the clay. But steel which is used in the construction has very good elasticity. A long steel rod, if I pull one of its end, again if I release my hand, it goes to its initial position. And it has a lot of elasticity. That's why it is used in the construction. Steel rods have very good elasticity, and that's why it is used in the construction. But the clay dough, it has very good plasticity. That's why once it is shaped, then it cannot change its shape by itself. It cannot regain its original structure. Okay, after all this explanation, I think time has come to verify whether we have a little understanding about this Newton's third law of motion or not. For this, I made some question. Look at this. This is a statement. According to Newton's third law, to every action there is equal and opposite reaction. Is this correct? Just evaluate this. I taught this just before this question. We have lot of idea about Newton's third law of motion. This statement is true or false. Just think about this. I'll tell you later. And I want to put an argument. Both the action and reaction forces act on the same body but in the opposite direction. What do you think? This argument is correct. Now, next argument, I want to put on next argument also. The action and reaction forces act on two different bodies in the opposite direction. Is this correct? Looking at all these, you have to find the correct option among these four. Now let's go through the option. What is written here? Only statement is correct. Is it? According to Newton's third law of motion, third law, To every action there is equal and opposite reaction. Yes, this is correct. But only statement is told. That's why maybe argument 1 and 2 correct. That's why we cannot say that option 1 is correct. We have to check argument 1 and 2 also, and we have to go through other options also. That's why the option number 1 is suspended. May be correct, may not be correct. Now let's go to 2. Only argument 1 is correct. This is wrong because only statement is correct. That's why only argument 1 is correct, not correct, but true. It will be better to have clear idea about argument 1 also. Both the action and reaction forces X on the same body but in the opposite direction. Is it? No. Action force X on one body and reaction force will be exerted by second body on the first. That's why on the same body is wrong concept. That's why argument 1 is incorrect. Now let's go to 3. Both the arguments are correct. This is not correct option because argument 1 is found to be incorrect. Statement and argument 2 are correct. We know statement is correct. But what about argument 2? The action and reaction forces X on two different bodies in the opposite direction. Yes, this is correct. That's why the fourth option is correct. Okay, let's go through some question also. Find the correct and incorrect arguments. Newton's second law of motion gives the definition of force. Think about this. Newton's first law of motion gives an idea about the inertia and definition of force. Just think about this. Steel has very good elasticity, so it is used in the construction of building. Correct or not? Think about this. Making the brick from the clay is one of the best example of elasticity. Is it correct? Let's talk about each of them. Newton's second law of motion gives the definition of force. No. First law gives the definition of force. Now Newton's first law of motion gives the idea about the inertia, yes, and definition of force. Yes, this is correct argument. Now third, steel has very good elasticity, so it is used in the construction of building. Yes, this is correct. Making the brick from the clay is one of the best example of elasticity. Is it? No, this is the best example of plasticity. That's why this is incorrect. Okay, I told you a lot about Newton's third law of motion, and we did a little elasticity and plasticity also. Now time is finished. This chapter is also finished. The whole force and motion chapter is finished. We'll meet in some another class. Thank you.